The Permian extinction, often referred to as the Great Dying, represents one of the most catastrophic events in Earth's history, a period when life itself teetered on the brink of near total annihilation. Occurring approximately 252 million years ago, this extinction event marks the boundary between the Permian and Triassic geological periods. The scale of this disaster was unprecedented, extinguishing about 96% of marine species and 70% of terrestrial vertebrate species. This article explores the unfolding of the Permian period's events and analyzes the potential causes of this immense ecological catastrophe. The Permian extinction was a prolonged event of unparalleled destruction, marked by a series of ecological upheavals that dramatically reshaped life on Earth. This period of mass extinction unfolded over thousands of years, yet its ramifications were so profound that they altered the course of evolutionary history. The scale of this disaster was staggering, with an estimated 96% of marine species and 70% of terrestrial vertebrate species becoming extinct. In the oceans, the impact was devastating. The extinction obliterated entire marine ecosystems, leading to the disappearance of once dominant species. Coral reefs, which had been teeming centers of marine life, suffered massive losses, drastically reducing biodiversity. The trilobites, a group of marine arthropods that had thrived for nearly 300 million years, vanished, marking the end of their long evolutionary journey. Similarly, other groups like brachiopods, ammonites, and various mollusks faced severe declines or complete extinction. On land, the scenario was equally grim. The extinction event wiped out a significant proportion of plant life, leading to a collapse of food chains. Large amphibians and reptilian species, which had been the dominant terrestrial vertebrates, suffered massive losses. The terrestrial ecosystems, once bustling with diverse forms of life, turned into barren landscapes. The loss of plant and animal life not only denuded the planet's landscapes but also destabilized the ecological balance, affecting the survivability of remaining species. This mass extinction also marked a turning point in Earth's climatic and geological history. The period saw dramatic shifts in climate and atmospheric composition, leading to harsh and uninhabitable conditions across vast swathes of the planet. The once stable and life-supporting environments turned volatile and deadly, contributing to the rapid decline in biodiversity. The Permian extinction's gradual unfolding meant that its full impact was felt over an extended period, allowing some species to adapt or migrate, while others perished. The aftermath of this ecological catastrophe was a drastically different world, with new species emerging and evolving to fill the vacant ecological niches. This event paved the way for the rise of new dominant groups, including the dinosaurs, in the subsequent Triassic period. In summary, unraveling the catastrophe of the Permian extinction reveals a period of profound and rapid changes in the Earth's ecosystems. It underscores the fragility of life in the face of environmental upheavals and serves as a poignant reminder of the dynamic nature of Earth's history, where periods of flourishing life can be followed by episodes of widespread devastation. The Permian extinction, often dubbed as the Great Dying, was the result of a combination of catastrophic environmental events and gradual changes that culminated in the largest mass extinction in Earth's history. Scientists have investigated various potential causes, each contributing to the drastic decline in biodiversity. One of the primary suspected causes is massive volcanic activity, particularly in the region known as the Siberian Traps. The extensive volcanic eruptions would have released colossal amounts of lava, along with greenhouse gases like carbon dioxide and methane, into the atmosphere over thousands of years. This sudden influx of gases likely led to significant global warming, ocean acidification, and a reduction in oxygen levels, creating uninhabitable conditions for many species. Another contributing factor is the theorized release of methane hydrates. These are methane molecules trapped within ice-like structures under the ocean floor. If released into the atmosphere, they could have rapidly accelerated global warming due to methane's potency as a greenhouse gas. This sudden climatic shift would have been catastrophic for species unable to adapt quickly to the changing conditions. Climate change during this period was also marked by a transition from an icehouse to an extreme greenhouse world. The Earth experienced severe warming, leading to the melting of polar ice caps and a rise in sea levels. These changes would have drastically altered habitats and climatic conditions, impacting species globally. The warming oceans are believed to have led to a decrease in oxygen levels, a phenomenon known as ocean anoxia. Anoxic conditions in the deep sea would have disrupted marine ecosystems, leading to the extinction of species dependent on oxygen-rich waters. There is also speculation about the role of an asteroid impact, similar to the one that contributed to the dinosaur extinction at the end of the Cretaceous period. While evidence for such an impact during the Permian period is less clear, it remains a potential contributing factor, capable of causing immediate and widespread environmental disruption. A combination of these factors likely created a cascade of environmental stresses that proved insurmountable for most species. The gradual accumulation of these stresses, coupled with the lack of time for species to adapt, led to the widespread extinctions seen during this period. In conclusion, the causes of the Permian extinction were multifaceted and complex, involving a series of interconnected geological, climatic, and possibly extraterrestrial events. The convergence of these catastrophic occurrences created one of the most challenging periods for life on Earth, reshaping the evolutionary path of numerous species and altering the course of Earth's biological history. The aftermath of the Permian extinction was a period of profound ecological and evolutionary changes, marking a significant turning point in Earth's history. The recovery from this mass extinction was a slow and gradual process, taking millions of years. The scale of the extinction had cleared a vast number of ecological niches, setting the stage for a dramatic evolutionary burst and the emergence of new life forms. In the wake of the extinction, the biodiversity on Earth was at an all-time low. The few surviving species faced a radically altered world, with many previously thriving ecosystems now desolate. The marine environment, which had suffered the most, saw the collapse of complex reef systems and a significant reduction in the diversity of marine life. However, these empty niches provided evolutionary opportunities for the survivors. One of the most significant outcomes of the recovery period was the rise of new groups that would come to dominate the Mesozoic era. In the oceans, this period saw the proliferation of mollusks, including the ancestors of modern-day clams and snails. Fish, particularly the ray-finned fish, diversified and filled many of the roles once occupied by now extinct marine creatures. On land, the Permian extinction had decimated the dominant amphibians and synapsid reptiles. This loss allowed for the ascendancy of archosaurs, including dinosaurs, which would become the dominant terrestrial vertebrates in the Triassic period. The empty terrestrial landscapes also paved the way for new types of plants, leading to the diversification of gymnosperms and the eventual rise of ferns and cycads. The recovery also witnessed significant changes in the composition and structure of ecosystems. There was a shift from ecosystems dominated by a few large species to more diverse and complex communities. This diversification set the foundation for modern ecosystems, contributing to the resilience and stability of life on Earth. In terms of geology, the Earth underwent significant changes. The end of the Permian period saw the breakup of the supercontinent Pangaea, leading to the formation of new continents and ocean basins. This tectonic activity played a crucial role in shaping the climate and habitats of the Triassic period. The Permian extinction and its aftermath highlight the resilience of life and the ability of ecosystems to recover and adapt in the face of severe challenges. It underscores the dynamic nature of Earth's history, where catastrophic events can lead to new opportunities for life and spur evolutionary innovation. The lessons learned from this period are invaluable in understanding the processes of extinction and recovery, offering insights into the current biodiversity crises and the potential impacts of human-induced changes on Earth's ecosystems. The Permian extinction serves as a stark reminder of the vulnerability of life on Earth to planetary-scale events. Understanding this ancient disaster is crucial, not just for comprehending the past, but also for preparing for future environmental challenges. The story of the Permian extinction underscores the interconnectedness of all life and the need for a careful stewardship of our planet's ecosystems.